Okay, everyone. So the homework tonight is to listen to this screencast and then to do the problems that I identify at the end of this screencast. So go to the notes that we were taking today and go to that last page. So I talked about how there are two kinds of roots of polynomial functions that have to occur in conjugate pairs. One of them is irrational roots, which we talked about in class. And then we kind of entered this world of imaginary numbers, and I kind of gave, um, you know, an impassioned speech about how hopefully this will rock your world in a very unsettling way, but unsettling and lovely at the same time. The other kind of root that also occurs in conjugate pairs then are imaginary roots. So if you look at this back page here, since imaginary roots have to occur in conjugate pairs, if you let f of x be a polynomial function that has roots at x equals 3i and 4 and nowhere else, where 4 is the root of multiplicity 1, okay, state all the roots of f of x. Well, you know already because you were told that, what just happened, that x equals 4 and 3i are roots, but also negative 3i is also a root, okay? So 4, 3i, negative 3i, these are the roots because these right here, imaginary roots, occur in conjugate pairs. Now, let's express f of x in factored form first, and then we'll express it in standard form. So f of x in factored form is going to be x minus 4, quantity squared, times x minus 3i times x plus 3i. Okay, now something is interesting is going to happen here. What I'd like you to do is go ahead and multiply those factors out first. Okay, x minus 4 squared. When you multiply out these two factors, you should probably land here, x minus 9i squared. All right, but no, you would never leave I squared as it is. You would write this as x minus 4, all that squared, times x plus 9, because I squared is negative 1. And this now is your f of x. Now, to go all the way through to standard form, you do have some work to do. You have to kind of multiply this out and write this as x squared minus 8x plus 16. And all I did was I just FOILed out x minus 4 times x minus 4. And then you'd multiply all that times x plus 9. This would now equal f of x. Now, I'm going to trust at this point that you could then continue doing this horrific FOIL and finish the job, okay? But the point is that not only do irrational roots of polynomial functions occur in conjugate pairs, so do imaginary roots. Let's do a new problem here. I'll change my pen color. What happens if I customize? Let's see, what colors do I have? Oh, look at these lovely colors. Which one would disturb you the most? Fuchsia. Here we go. So let's say that f of x has roots at x equals 2 minus 7i. Okay? If f of x has a root at 2 minus 7i, let's see. And there are no other roots other than possible conjugate roots. Okay? First of all, if f of x is a root at x equals 2 minus 7i, a second root has to exist where? A second root would have to be x equals 2 plus 7i. Remember, because again, these two here are conjugate pairs, and hopefully you see the similar relationship as the irrational roots. It's 2 minus 7i, 2 plus 7i. The 2, the sign of the 2 does not change. Now what I'm going to do is go back and write f of x in factored form. So let's see, f of x then would equal, this is where you have to be careful, this is when Talia said, everyone be careful, x minus the root 2 minus 7i times x minus the root 2 plus 7i. Okay, now here's what I'm going to ask you to do here. Here, I actually do want you to multiply this out and write this in standard form. And I think I need more room Can I get more room? Let's see, can I? Oh, the snip isn't, oh dear. Okay, well, I'm just gonna go up here and squeeze it in, okay? Now, when you write this in standard form, you have to be careful here. The first thing I'm gonna do is carefully distribute that negative. So now I get x minus 2 plus 7i. Do you see how I got that, everyone? Times x minus 2 minus 7i. Now you're going to have an extended FOIL, right? You've got to do x times the x times a negative 2, x times a negative 7i, and then do this, this, and then the pot, right? All that. Now, why don't we do this? On your honor, everyone, go ahead and try this and see if we can all land at the same place. So I want you to pause me now. Pause me. All right, here is me having just done the extended distribution. I ran out of line here, so I had to loop it down low. Now, a couple of lovely things happen. There's some nice cancellations going on. Negative 7ix plus 7ix plus 14i minus 14i. And then this becomes, let's see, f of x equals, oh, sorry for this mess. The rest of this is on a nicer place. X squared minus 4x plus 4 minus 49i squared. But you know, you would never leave that as 49i squared. You write this as positive 49 because I squared equals negative 1. At the end of the day, everyone, we get x squared minus 4x plus 53. How about that? And there is your function, okay? All right, let me go now to my second piece of paper. Where is it? There I am. Okay, so a couple things. When you are looking at polynomial functions with imaginary roots, okay, for the purposes of our work this year, imaginary roots, right? Imaginary roots do not show up graphically. So that polynomial function we just graphed, that we just found in standard form that I just clicked out of, I think it was, what was it, f of x equals whatever it is. If you go ahead and graph that on your graphing calculator, you will see that there are no roots, because I think that question was the roots are here and here, and there were no other roots. So imaginary roots do not show up graphically, okay? Something else to keep in mind is the following too. Not only do imaginary roots not show up graphically, they don't alter the graph in any significant way yet, all right? So not only do the imaginary roots not show up graphically, right now, without calculus later on, right, for us to talk about, well, what do they do to the graph? We really can't appreciate it quite yet, but very soon we will. So now I'm going to take you to an example of a homework question. Let's do a homework question together, and I'll just take this off of homework. How about that? If you look at page 314 and look at question number, let's look at question number 43. This is a great question. Let's do it all the way out. Question 43 says that f of x is degree 3, okay, and the roots include, I'll write it out just in case you don't have your book in front of you, include x equals I and x equals 1. You're also told that f of negative 1 needs to equal 8. And here are the instructions. Find f of x. All right. Well, this is a nice question because now this question pulls everything we did together in class today. So the way we go about this, everyone, and maybe you could even kind of play along the script in your head as I go along. Well, what do? Well, it's very clear that if I know my roots are, okay, if my roots are x equals I and x equals 1, and if I know that imaginary roots have to occur in conjugate pairs, I know that negative I has to also be a root. Now, what about the fact that f of x is degree 3?
what does the fundamental theorem of algebra say? And if you really want to make sure you're on your toes here, you wouldn't just let me say it to you. You'd hopefully go back and look it up. But the fundamental theorem of algebra says that if you include all multiplicities, and you include all irrationals, and you include all imaginaries, the number of roots total, when you include all of those things, should equal the total degree. What that means is, if I'm degree 3 and I've identified 3 roots here, I know for a fact there are no other roots lurking in the background. So far, I could say that f of x has to equal, let's see, here are now my factors of x minus I times x plus I times x minus 1. Okay? Generally speaking, boys and girls, I'm going to give you a really helpful hint. When you have imaginary factors, if it's convenient for you to do so, I recommend multiplying those conjugate factor pairs because it'll often land you someplace nice like this. Okay, and if you want to know how it is that x minus I times x plus I equaled x squared plus 1, come over here and FOIL it out with me. Right? Cancel, cancel, and I'm left with x squared minus I squared, but I squared you know is -1, so this is just x squared plus 1. Okay? All right, now here's the other detail. We have to incorporate this. F of -1 equals 8. That means when x equals -1, y has to equal 8. Is that true now? Go ahead and plug in -1 in for x. When you plug in -1 in for x here, I get 2 times -2, right? 2 times -2 is certainly not 8. Well, but I know that if I have a function in factored form, I could multiply those factors by any constant k, right? And the question is, what would k be such that when y equals 8, x equals -1? And let's really watch our negatives here, okay? This becomes 8 equals k times 2 times -2, and 8 equals -4k, -2 equals k. So at the end of the day, look what I've done. You have found the function to be -2 times x squared plus 1 times x minus 1. Look at that. Really nice job. Really nice job. Oh, you know what? What would the graph of this look like? Well, let's see. Root at +1. The other 2 roots are imaginary, so we don't know what's going on there. We know it doesn't affect this function at all. Lead coefficient is going to be negative, so it looks like the right end behavior is going to be falling. The left end behavior is going to be rising because the degree here is odd. We know part of me wants to just draw a straight line like this, but when I look at this here, I know this can't be a straight line because a straight line would be degree 1. So right now, at this point, everyone, we could just say maybe it's doing something like this. Who knows? We don't know. The function could look like that, maybe. All right? That's it, everyone. Let me give you your homework for tonight. Your homework is going to be on page 314. I'd like you to do the following. Numbers. Let's see. 33 is going to be a little bit meaty. Do 33 last, okay? Do 33 last, and then I'd like you to do 36. And we can take a walk down, well, let's see what you do with 51. Try 51 as well, all right? We'll talk about those in class tomorrow. Have a great day, night, and I'll see you mañana.